Hello world, this is your electron buddy. So today we'll be looking at how to test transistors. So firstly we will check at how to identify the terminals of the transistor. Secondly we will check how to test the transistor using digital multimeter as well as analog multimeter. And thirdly we will do a HFE test on one of the transistors. So let's go ahead. Here you can see four types of transistors in different packages. The first two are the BJTs, and the next two are power transistors. So this one is BC557. So this one is BC108C. This one is IRF 540N, which is a MOSFET, and this is a 2N3055, which is a power amplifier. So here we will be covering testing on BJTs. So we will not be covering these two transistors. So if you want to look at the different packages, you can visit the EBC site. So here they have listed almost 23 different types of transistor outline packages. I'll put a link of this in the video description so that you can have a clear view. Okay, let's go ahead and test these transistors. Whenever you find a transistor in your hand, the first two primary questions that come to your mind is, how will I identify whether it is a PNP or an NPN transistor? And secondly, how will I identify its terminal, as to which terminal is its emitter, base or collector? So let's see how we can approach these two questions. Let's see how we can identify the terminals first. So here we have a BJT in a plastic casing. So here you can see, if I turn it on the top side, here you will notice that the one side, the bottom end is a flat side. So this is a flat side and the top end is a semicircle. So what you have to do is face the flat side towards you, and then you have to measure the terminals from left to right. So in case this transistor is an NPN transistor, so this terminal on the left is your collector, and terminal in the middle is your base, and terminal at the last is your emitter. So in case this transistor is a PNP transistor, so the terminals reverse. So now this, which was earlier a collector, becomes a emitter. This one is a base, and this one, the last one, is a collector. So similarly, so for BJT in metal casing, to identify the emitter, base and collector junction, here you can see a notch, extrusion you can say, that has popped out the metal. So in case this is a NPN transistor, so terminal next to this extrusion, small pop out, is the emitter. So this is the emitter, the center one is the base, and the last one is the collector. So in case it is a PNP transistor, now this becomes the collector, the center one becomes the base, and the last one becomes the collector. So that's how we identify the terminals. Here you can see 3 transistors being inserted into a breadboard. So with breadboard it becomes easy to handle the terminals of the transistors. So to identify whether the transistor is a PNP or NPN, I will be using a digital multimeter. So before moving ahead with identifying whether the transistor is NPN or PNP, let me just give you a quick view of two diode analogy for bipolar junction transistors. So here you can see the two diode analogy for NPN transistor and PNP transistor. So in this case, the diodes will be connected in opposite fashion. So the transistor is nothing but in this analogy the transistor is nothing but two diodes connected in opposite fashion. So for NPN transistor, base will be on the positive and the emitter will be on the negative side. So in this case the diode between base and emitter will be forward biased and we'll get a continuity between base and emitter. Similarly for base and collector, the base is on the positive side, the collector is on the negative side. The diode becomes forward biased and we get a continuity between base and collector. If suppose emitter or collector on the positive and base being the negative, so in that case the diode will be reverse biased, so we will not get a continuity. So same applies for PNP. The only difference is that the base will be negative over here and either of the two terminals will be positive. So let's go ahead and test the transistors based on this analogy. Before moving ahead with identifying whether the transistor is NPN or PNP, make sure your multimeter selector switch is on the diode position or the continuity position. So after making sure, you can switch on the multimeter. So now we'll go ahead and test the transistors. I have considered 3 transistors which are BJTs. So the first transistor is a EBC 547. So let's go ahead and check whether it's a NPN or PNP transistor. So I'll connect the positive terminal to the center of the transistor and connect the negative to one of the terminals on the other side. So here we are getting the reading. So for the second terminal as well we are getting the reading. So this is a NPN transistor since the base is positive over here. So likewise, if I change the terminals, we should not get the reading. So here you can see, so there is no reading. So in this case, I change the terminal once again. I make the base positive. Now I get the reading. Here also I get the reading. So EBC 547 is a NPN transistor. We can verify this by looking at the data sheet as well. So here you can see, here it is clearly saying it is a NPN transistor. Here you can see it is clearly saying the transistor is a NPN transistor. So likewise, we'll go ahead and test EBC 557. So we'll consider this on the negative side on the center and take this. Yeah, we are getting the reading. Likewise for the other side we are getting the reading. So in this case EBC 557 is a PNP transistor, the base being negative. So we can verify this with the data sheet again. So we have EBC 557. So here you can see they're clearly saying it is a PNP transistor. So the multimeter test is being verified. So next we will go ahead and check the metal packaged transistor. So same, we'll apply the positive side on the center, that is the base, and then we get a reading for either of the terminals, likewise for the other terminal also. So in this case this is a NPN transistor. So again we can verify it by using the data sheet for this transistor, which is EBC108C. So you can see clearly it is mentioning NPN transistor. So here we can see that the digital multimeter gives us positive test results in identifying whether the transistor is a NPN or PNP transistor. Before moving ahead with the HIV test, I would like to demonstrate one more method of determining NPN or whether the transistor is a NPN or a PNP. that is by using an analog multimeter. So this test can also be applied when you don't have a continuity test function on your meter. So in that case you can use this test. So in this test you just have to put your selector switch in the ohms range to the lowest value. So let's go ahead and check. So before going to check, notice here that I have changed the terminals patch cord position. I have used red on the negative, that is common, and the black one on the positive. So yeah, normally it is vice versa, but for this test I have used interchanged the patch cords just to avoid confusion, because in this test we'll be checking the resistance between the terminals. So to avoid confusion, I have interchanged the patch cords. So now this is my positive, this will indicate the P junction, and this will indicate the N junction. Let's go ahead and check the transistors using the analog multimeter. So first we'll test the BC 507, which we already know is the NPN transistor. So let's go ahead and check. So we'll apply the P junction on the terminal of the multimeter, indicating the P junction in the center. Then we get, here we go, we have a deflection. Also here we get a deflection. So this is how the transistor is determined as NPN using a multimeter, analog multimeter. We go ahead with the BC 557 transistor, which earlier was a PNP transistor. So let's see with this analog multimeter. So here we are not getting the deflection, so I'll just interchange the terminals, and here we go, we get the deflection. So this is the P junction, this is the P junction, this is the N junction. So this is a PNP transistor. Similarly for this metal packaged one, go ahead, we are not getting a deflection. We interchange the terminals, we put the terminal in the middle, terminal of the digital multimeter on the middle terminal of the transistor, and we get a deflection. So this now is a NPN transistor. So this is how we test the transistor using an analog multimeter. Just make sure that you interchange the cords. Just apply the red one on the negative side and black one on the positive side. Keep your selector switch on the resistance range at the lowest value. So these three things you have to keep in mind. Okay, here I will demonstrate how to perform a HFE test on transistors using a digital multimeter. So I have used transistors BC 507 and BC 557, which are nothing but NPN and PNP transistors, as we have seen in our earlier test. So what basically is HFE? So HFE is a constant. It is also known as DC current gain, and it is the value by which the base current amplifies to give us the collector current. So HFE is unpredictable and varies between standard values of 20 to 500. Sometimes it goes below 20 also. So let's go ahead and check out the HFE value using the multimeter. So before moving ahead, first make sure that the selector switch is on the HFE range of your multimeter. Then switch on your multimeter. So in this case we are using BC 507. This is nothing but a NPN transistor, and as we know that NPN transistor, so the first terminal, the left hand terminal, is our collector. So here we can see the collector, the left terminal, which is the first terminal. So on the multimeter here you can see two types. This is the NPN and PNP. So we will be using NPN terminal, NPN slots for this, for inserting this BC 507. So since this is the collector, I'll make sure that it is inserted into the collector side. So here you can see we get a HFE value of 311 almost for BC 547. HFU value is 307. So the value we got this value. So the value is based on the base current. So your digital multimeter will be applying the base current to your base terminal. So this base value can be found out by your multimeter manual. So in my case the current is almost 10 microamps. So I can get the collector value by multiplying 10 microamps. So 10 microamps into 307. So it gives me almost 3 milliamperes of base collector current. So similarly, we can go ahead and test the PNP transistor. So here the first terminal is emitter. So I will make sure to insert it in the PNP slot as per terminals. So here we go. Yeah. So here we are getting a value of almost 7. Yeah, we are getting a value of 7. So in this case BC 557 HFE value is 7 microamps, but 7 gives us almost 70 microamps. So this is how the HFE test is being performed. I hope this video will help you testing transistors. So if you find this video interesting, kindly like the video and subscribe to the channel. Thank you.